Okay, we've identified a lot of characteristics of our function, and now we're ready to make a graph. Almost ready. Maybe before we actually start drawing, let's identify some points on the function. Right? So the formula, our original function formula, g of x is 10x minus 20 divided by x squared. We know the function is undefined at 0, not defined at 0. We know that the value at 2 is 0, and we know that 4 and 6 are important points. If I plug in 4 for x, I get 40 minus 20 divided by 16, so 20 divided by 16, or more simply, 5 over 4. And the value when x equals 6 becomes 40, 60 minus 20, divided by 36, which is 10 over 9. So both values are slightly larger than 1. To be able to make our sketch carefully, let me add one more point, negative 2. We haven't looked at the value at a negative number. If I plug in negative 2, I get negative 40. Divided by 4, which is negative 10. So with those kind of specific points in mind, and with the information we have about increasing and decreasing versus concave up and concave down, we can create a nice sketch of our function. I'll draw a coordinate plane here and plot out some of our important points. So I guess first let me mark the asymptotes. Y equals 0 is an asymptote, and x equals 0 is an asymptote, so the two axes will serve also as asymptotes. And then I know the function has an x-intercept at 2, so let me mark that there. I know at negative 2 the value is down here at negative 10. And then at 4 the value is slightly positive at 1, 10 over 9. 5 over 4. And at 6, the value is at 10 over 9, so slightly below that. And now let's think about the characteristics from the derivative. For negative values, the function is decreasing and concave down. And I know that at negative 2, the value is negative 10. So the graph must drop down from the asymptote and then look something like that. And let me extend the vertical asymptote there a little bit. And then on the other side, between 0 and 4, the function is increasing and still concave down. So it passes through 2, 0, and then reaches a peak at 4. It only drops down slightly as a concave down function. It only drops down slightly. And then it becomes concave up as it works to flatten out and follow the horizontal asymptote. And so there we have it. This is a rough sketch of our function. It's increasing from 0 to 4, then decreasing but still concave down until we reach 6, and then it's concave up and still decreasing but concave up.